All right, this video is going to cover Inly's summer program, which is a combination of a bunch of our courses into a single, larger, coherent curriculum. So to give it some context, let's look at what winning firms have in common today. So one thing that a lot of winning firms have in common is that they have this advantage of scale efficiency, which just means that they're big. So a great big company, can buy things in bulk and get discounts and achieve other kinds of economies of scale. But the other thing is perhaps less obvious. A lot of the more successful companies in the world have extreme operational efficiencies. They get things done faster using less resources, and not just because they're bigger, but because they're data centric. And data centrism, when I say that, what I mean is first, they're actually generating data. So they have sensors in places and they're keeping track of who said what and what kinds of transactional things happened. They've got structured and unstructured data, and they have it going somewhere where they can use it. So they're generating that data, and when I talk about having somewhere for it to go where they can use it, they're structuring it so that it's accessible and it's usable, whether that's in a data lake or some other kind of system. And then they're actually making use of it. So of course, generating it and organizing it are prerequisites for the purpose of utilizing it. So they're able to simplify and automate processes using that data, but it's also informing their decisions. So it's not just about automating workflows or simplifying or expediting workflows using data and software development. It's also about using data science methods to mine that data for insights that then inform your decisions. And there are, of course, some companies, that darker circle there in the middle represents the overlap, right? There's some companies that are both big and data centric. Those companies tend to really do well and really stand out as winners today. So if you think about just one market here, and I've got that kind of like mustache looking graph there with the Venn diagram of the two overlapping kinds of circles. So you've got big companies, you have data centric companies, and in the middle, you've got the big data centric companies. And that outer circle maybe represents whatever industry these companies are in. As time goes by, especially when times are tough and it's harder for companies that are less efficient to survive, as time goes by, these companies that are bigger, that are more data centric, or both, expand and take over more of their markets. And that's true for a lot of markets. And so gradually we start to approach something that just looks like this big eye here. Where it's the big companies that are data centric that are really kind of standing out, taking up more space in their industries. So how does this translate to what you should do as an individual? The concept here is when you ask that question, you might be asking the same thing as, what do these kinds of companies want from me? How can I be relevant to winning companies so I have a place in the economy? If you want to join a big company, you can join a big company. Big companies are working to be data centric the same way that small companies are working to be big. So, both kinds of companies are looking for people who have what I call the data centric skill set. So that data centric skill set has four parts, the way I see it. The first part is innovation acculturated. So if you're innovation acculturated, that means that you are looking for ways to do better. You don't take a job description and the pre-existing workflows that define that job as like a set thing that you then just do. Once you learn how to do it the way it's been done, you just do it again and you do it again. Instead, you're always looking for step change opportunities. How can you do better? How can you make things work faster? And what kinds of things can you automate and cut from the original workflow? So that requires some acculturation. You have to get used to thinking about what could be true, even though it's risky and it might not work. And so you have to kind of get good at trying things really quickly and cheaply on top of getting the regular work done, mitigating all of the risks that come from attempting to achieve innovation. The next part is data-driven. So these kind of go together and they sort of blur together a little bit at the middle there. But data-driven just means that you are able to use data in order to inform your decisions. And that doesn't necessarily have to include contemporary data science methods, but it often does, and those are really helpful. So if you've discovered something that might lead to innovation and you want to give it a try, you need to know what kind of data you need to collect and where that data is stored, and maybe what kind of people need to help you with that endeavor. So the next part here is project oriented. So whatever your project is, whether it's a project that's been has a precedent in your company already, or it's a brand new type of project that's meant to lead to innovation, you need to be able to figure out accurately ahead of time what resources you need to achieve it. And ideally, you're very optimal in how you do that. So you're minimizing the resources that it takes to get the work done. And then finally, software proficient. So you don't have to write all your own software, but if it's a small enough project that can be done quickly enough, or it's specific enough to an individual workflow, then it's probably, if any of those things are true, it's probably a good idea for you to just go ahead and build it yourself. So people who have this software proficiency are kind of like the equivalent today of people who had word processing skills in the previous step change of standard of workflow contribution or contribution in the workplace. So used to be you'd hire people who had some sort of skill set, but if they could do things on computers, hey, that was great. And people used to put on their resumes, I know all about Microsoft Office products and that sort of thing. Now, if you put on your resume that you have some software skills, it's kind of the same. It's like this is a rising new standard of what is expected from employees. It doesn't mean that you have to build really complicated and advanced software. You might be buying stuff that's off the shelf in your company. But if you're trying to do new things, especially, then that's a good thing to have some software proficiency yourself. So some examples of these things: innovation and acculturation. Those are things like the design thinking toolkit. So you empathize with whoever you're trying to solve a problem for, and then you narrow down and define a very specific problem, so that when you get really creative and try to come up with all kinds of wacky solutions, they're tethered to a very well-defined problem. That way, you're not wasting your time being too creative and spontaneous without anything to kind of bound it. And then you rapidly prototype to try to get through all of those different ideas you came up. Startups and the startup process and sort of best practices are really great to learn about if you're trying to be innovative, even if you're working for a great big company. And then, of course, trying to automate processes, that's a really important step. So what kind of processes can be automated? Once you've identified that, how do you then explore that very quickly and cheaply? For data-driven, these are just examples of machine learning methods, k-means and random forest and the support vector machine, those sorts of things. But data-driven doesn't necessarily mean that you're using contemporary data science methods. It could also mean that you're just collecting data, and it's more simple than that. But your predecessors maybe were not collecting that data, when we're looking at it, and we're going more based on their guts or what felt right or that sort of thing, as compared to really informing those decisions with data. Project-oriented, I'm thinking about things like Agile and Scrum, but I'm also thinking about like pseudocoding. So that kind of bleeds into the software proficiency part, where you might be using tools like Visual Basic or Python or SQL. Visual Basic is perhaps dwindling in its popularity in the world of software engineering, just because of the power of things like Python, scripting languages like Python. But because so much data is stored in Microsoft Excel, and because Excel is so paramount to so many pre-existing workflows, knowing how to automate things using Visual Basic in Microsoft Excel is still a really good skill to have generally. So last part here I wanted to talk about is this data science component. So it might make sense that, okay, like we need to be automating our processes wherever possible. But what about this data science stuff? Why mention methods like k-means and support vector machines and that sort of stuff? Why do we need to focus on that too? And why now? Why hasn't that been an issue so much in the past? So I think there's two reasons for the contemporary like resurgence of data science popularity. One is this increase in computing power, which has been pretty gradual for a long time. The second is increase in the availability of data. So we can now do more things with data, and we now have more data at our fingertips to do things with. So here's Moore's law. There's a lot of small font here, but the point is that every 2 years, the number of transistors on an integrated circuit doubles. And that's been pretty true for quite a while. So cool thing looking at 1970 all the way to 2018 and beyond, and seeing that on this log scale transistor count, we have a nice steady slope here showing it's doubling every couple of years. And what that means is that computers can do more faster, the average computer. It also means that computers get cheaper, and as they get cheaper, it becomes possible with transistors are so much smaller on circuits that you can fit more than one processor on a computer. So now parallel processing is something that can be done on the average computer, and that average computer can handle methods that are very like expensive computationally by standards of only just a few years ago. So it becomes possible now for all kinds of people to use data science methods to do all kinds of cool stuff. It used to be just kind of like limited to people who had access to supercomputers or things like that. So that's the first reason. The second reason is a big increase in the availability of data generally. So there's a lot of people around the world, a lot of organizations around the world collecting data sets, but they're also sharing them. So about the collecting part, here's something that the International Data Corporation published back in 2018. They said that from then through to 2025, worldwide data would grow by 5.3x to about 175 zettabytes, which are billions of terabytes. So think about a terabyte as maybe the size of an average computer, talking about all the data that you could fit on billions of terabytes. So hundreds of billions of terabytes of data total. And then, like I was saying, more of the data sets are more available generally. So these same organization, International Data Corporation, predicted that 49% of the data would be stored in public cloud environments by then, with nearly 30% of the data analyzed in real time. So public cloud environments, there's also a lot of talk about publicly accessible data, and that's become more and more the trend. So for all these reasons, data science has seen that popular resurgence. So one last thing to cover here, and that's about when you do start to learn software. I talked about the data science part, so let's talk about the software developing part. If you want to get good at developing software, here's some things that are kind of like maybe weird about it when you first get started. So here's a Zoom meeting, and Zoom is a piece of software, right? And it fits a very specific need. It helps us to schedule, and then it runs meetings for us. I'm recording this video using Zoom. So I can just click on schedule a meeting up there in the top right. Then I fill in stuff in a nice little template with drop-down menus, and little guided user interface options and things like that. So it's a very like fit for purpose tool. When you're using Python, for example, often you start off with something that looks just like this, or something like this. So you just have this blinking cursor and this line. It's like, what do you want to do with Python? The reason why Python looks like this and Zoom looks like this is that Python is not designed for handling a very specific purpose. And for that reason, it's like much more versatile, but it's harder to set up the very first time for anything you want it to do. So, if you have a question like, why can't I just click or drag or toggle on drop-down menus or other things like that to make it do what I want it to do? That's the reason, is because what toggles would you add? What kinds of things would you add in drop-down menus? Python doesn't already know what you want it to do. You have to teach it to do specific stuff, but it's very powerful in that it's very generally applicable to do all kinds of interesting things. So for example, if our goal was a conference call, and you think about what's the extent to which we have to build the tool ourselves just to like set up a conference call. And let's just consider the very first time we ever use the tool, the very first time we set up and use the tool. So if we have this line here, upper right means that we're having to build the tool ourselves a lot more, and it takes a lot more time the very first time we do that setup. Then we want to put zoom somewhere on that line. It would be very bottom left because it takes very little time to set up, and you don't really have to build anything yourself. You just have to create a login, username and password and that sort of thing, and then you're ready to go. So it's very easy to use. Versus Python would be way up here. It takes a long time if you wanted to use Python as your conference call tool, because you would have to basically build something like Zoom in Python, like WebEx or Skype or whatever you're using, Teams inside of Python. So similarly, if your goal is sending an email to someone else, if you have Microsoft 365, it goes down here in the bottom left because it's really quick to set up, and you don't have to build anything yourself. Versus Python, if you want to use Python as your email software, then you'd have to build something in Python in order to do that. So you have a lot more time devoted to building it yourself, and the time required for the very first time you use it goes way up too. So what if your goal is doing something like uploading data from a certain file format in Excel? So the data is stored a certain way across sheets and Excel files, and you need to check various conditions in that data. And then based on dependencies of those conditions, you have to then do things that with that data. Sounds like how we spend our time at work, is moving things around and understanding those dependencies and conditions and that sort of thing. So if you want to use Python for this, Python is still Python. Like, you still have to tell it how to do what you want it to do. So the time required for the very first use is going to be like higher. And that's because you have to build it yourself. But there is no tool that just does exactly what you need it to do in all of your workflows for you. So there is no like off-the-shelf tool necessarily that does this number 3 task. And those are the kinds of tasks you want to identify when you're learning how to develop your own software. And if you get a little experience with this, you start to realize like when it's possible for you to just develop a tool yourself that then you can use again and again. And when it's practical and actually useful to do that. So let's position the 3 goals that we talked about on here. So we've got how long it takes each time to set up, and then how often you have to do the workflow in the same way. So if you have a conference call, we might put that at the bottom right there because it's really fast each time, and you often do the workflow in the exact same way. Whenever you set up a conference call, you set it up in pretty much the same way. You might change little details like who you're inviting or when the conference call takes place, but that's a pretty repeatable workflow, and it comes up pretty often. If your goal is sending an email, well, that goal kind of goes down there with the first goal. You might include different content and include different people and who you're sending an email to, but the way that you actually type an email, those options are kind of predictable in their scope, and you do it pretty often. And maybe for this number 3, you have to do it quite a lot, but it takes a really long time each time you do it currently, manually, the way that you do it before you learn something like Python. So what's really special about tools like Python is they take this curve we've talked about, this line here, and instead of it taking a really long time each time, it only takes a long time the first time. So if you think about the time required for the next use, Python really drives that down. So then, Python starts to act more like Zoom or Microsoft 365 to do those sorts of workflows that, that are much harder, and that there aren't already tools out there that just take care of them for you. So you can build your own tool to take care of those sorts of things. It takes a while the first time, but once you've set it up, then you've earned back a huge amount of time at work. And that's the automation and workflow optimization kind of magic that Python can offer. one last way to sort of break this down, if you look at how long it takes each time you do some sort of recurring task, and then how often you have to do it the same way. So rather than draw like a curve, let's break this down into like 4 quadrants. So for the how often you have to do a workflow in the same way, maybe we just kind of draw a line and put everything on one side or the other. So there are tasks that we only do seldom, and then there are tasks that we do often. So to break down how long it takes each time we do those tasks can be either slow or they can be fast. And then if we ask, like, what percent of our time does each one of these 4 boxes take up? Just based on their definitions, we can kind of fill that out pretty quickly. So I don't know if 5 is the exact right number here, but for things that are very quick, even if we do them often, if they're very quick, they don't take up very much of our time. If they're seldom, we don't do them as often. Then that also takes up a small amount of our time, versus if they are things that we do that are slow, that don't take up, or they take up a lot more time than things that we do seldom and things that we do often. If they're slow, right? So something that you do often that takes a long time, well, then it takes a huge chunk of your overall time, because it's both slow and often. So that gets a much higher percentage than stuff that is slow that you don't do as much. So overall, the highest percentage box is here. And that's when you should be using Python. If it's something that you do the same way often, well, then that means if there was a tool that automated that or expedited that, then it would drive down the total amount of time that you're working to get the same amount of work done, which now frees you up to do more work or to add more value by figuring out creatively what else you could do with your time, what other technologies you could incorporate into your firm, or what other kind of step changes you can make in efficiency. So once you kind of get into this, then this is the kind of thing that you can accomplish. So Inly's summer program was all about these 2 parts of that 4-part skill set. So we talked about the 4 parts, and the innovation acculturation is kind of one bookend, and then the actual practical software development is the other. And this summer program covers some aspects of each of those 4 things, but really focuses in on 2 parts. First, how do you actually write software to automate things, but to also do data science? And how do you write software? We talked about Python, but we also do a bunch of Visual Basic, which is the software developing language that comes with Microsoft Excel. So there's so much work that happens already in Excel. There's so much data stored in Excel. You can move things into Python and do the work in Python and then output back into Excel. Sometimes that's better, but sometimes it makes sense to just do the work right there in Excel, especially if you're creating tools that other people then are going to use who don't have a Python background. Or perhaps if you're working on data that your company won't let you move around into different formats or access through different tools other than something like Excel. So that's really where the rubber hits the road, is that intersection between Python and Excel in a lot of companies and a lot of organizations' workflows. So there you go. That's the point of the course, the entire summer program, which is one course kind of as a combination of a bunch of courses, and the context for it. I hope this is